In this video, we're going to focus on how to find zeros or roots for polynomial functions. Now, this is the third theorem. It is called the rational root theorem. So from this one, we can tell that the matter of fact is to find the rational root. So here we say, add a third concept. This is after the other two theorems. And also to say to make finding zeros or finding roots of a polynomial function easier. In other words, it is not that easy to find solutions or roots of polynomial functions. Matter of fact, it's just tedious. Now later on you can see what I mean. Now take a look at an example. This is a quadratic function. In order to find the roots, of course, we can use factoring. And basically, so far, we always use factoring to find the roots. But a different way to think about it, supposedly you do not know how to factor this. So then the first way to think about it is that you know if quadratic function that possibly have two roots, and then that means you have got two factors with no remainder, or remainder is 0. So in terms of that, you only have this different choices. So that means your -8 for the constant, or just, -8, that only has a possibility of break it into positive -8 or positive -1 there, because in the end they multiply together to give you this -8. So the possibility to break that, it is only this possibility or this possibility with this possibility, or this type of breaking to make a -8. All right. Also note, so this is a 8, 4, 2, 1, and that is 1, 2, 4, 8. All right. So yeah, so that's a pattern, because of the 1 multiplied by 8 or 8 multiplied by 1, there's the same thing. Therefore 2, 4, 4, 2. So this kind of possibilities. So in this case, if we do this type of breaking, then you will have a 3x plus 1 equal to 0. So then you would have x equals to -1/3, or you will have 3x minus 0 equals to 0, then you will have x equals to +1/3. So this is your possible two zeros, and similarly, then this is your possible two zeros, and then you go down to this choice of having two binomials, then you got this choice and this choice. So in the other another way to say is you got this many possibilities of possible zeros. So you list them up in a way that you do the integer first and you do the fraction second. All right. However, another way to look at it, so also another way to look at it, you don't write out like this. It's fine. So as a matter of fact, it is really the possible factor of 8. So the possible factor of 8, this is this. The possible factor of 8 is this one with that one, that one with that one, that one with that one, that one with that one. So then that becomes just the 4 of them, because the other two, they're the same thing. The other 4 is the same thing, supposedly to be 8, but it's just the 4 possibilities. Now you're also if you write this into a squared plus bx plus c, but this is equals to 0. So your c, to break the c, has this many possibilities, and your possible way to break your A has this many possibilities. So then in the end, your roots will be just over this one. The possible roots is this one over this one. So then it gives you, so the negative 1, negative positive 1 over that, give you this one. Negative 2, this, give you this one. And the 4 over 1, this one. 8 over 1, this one. Now this is almost like the not combinatory, well, sorry, that's word, is the combination of how to find the possible solution. So now you have this one over 3, this one over 3, this one over positive and negative 3. I'm just trying to not use too much energy to speak like this. So positive and negative 8 over positive and negative 3. So then in this case, you got these fractions as your possible roots. All right, so this is just very tedious. So in this case, when you try this one, you tried positive 1 to see whether or not, you know, the P1 is equal to 0. So you want to try the P1, whether or not your remainder is 0. It turned out to be not 0, because let's try this. This is 1, so this is 3, and this is 1, this is 2. So 3 plus 2 is 5, and 5 subtract 8 is negative 3, so it's not 0. You try negative 1. Negative 1, same thing. So this is 3. Now this is negative 2. 3 minus 2 is 1. 1 and negative 8 is negative 7. So that is not 0 either. Okay, so you try 2. All right, so you try 2. 2, okay, 2, 2, 6. Sorry, 2, 2, 4. 4, 3, 12. And then there's a 4. 12 plus 4, 16. 16 minus 8, still not 0. Okay, well then you try negative 2. So then negative 2, this is positive 4. And then so this positive 12. And then this is negative 4. And this is negative 8. Oh yeah, finally, this is 0. All right, so now if this is 0, then you can use 3x squared plus 2x minus 8 divided by x plus 2. And then you would have your other factor here. So if we just review this division, then this is a 3x. So then 3x, this is 3x squared. And then that is 6x. 2x subtract 6x is negative 4x. And then minus 8. So then in this case, then this will be negative 4. So then negative 4, it is negative 4x. And then that is negative 8. And then here's a 0. So your other factor is that. So then your two factors is here. And therefore your two roots is that. So this is just supposedly we do not know how to factor it. We can only write it out as the possibility of the these factors. Okay, so now let's take a look. So this is your rational root theorem. So if you got this is your polynomial function. And now note here, it says the integer coefficient, because in this case, if you have a rational roots, the coefficient has to be integer. If this is just a real number, then your roots might not be rational roots. Some of the roots might be irrational roots. All right, so this is important to be noted. And then your every rational zeros would have, so P is the factor of the constant, the last term, and the Q is a factor of the leading coefficient. And then your roots will be this, P over Q, as your rational roots. All right. So this is a rational zeros. That's a factor of the constant on top divided by the factor of the leading coefficient. Now take a look at this example. So this is, we have a cube function here, or cubic function here. All right. So now let's list up the coefficient, the constant, which is -12. So -12 could be, so if we say 12, that could be 1 and 12, or another one is 12 and 1. So if this is easier for you to write, then that's fine. So just switch them. Or there will be 2 and 6. So note, we always start with a small number, and or 6 and 2. So they're basically the same thing. And then now I go to 3 and 4, or 4 or 3, right? So in this case, you would have negative positive 1, negative positive 12, negative positive 2, negative positive 6, you can see also that, negative positive 3, negative positive 4. All the other ones is basic switch, so it's exactly the same thing. And then your P here, sorry, that's not a P, the Q here is only positive and negative 1. So then your possible roots is this over it, but we're very thankful this is only 1. So you don't have fraction here, so you only have these possible roots here. So what you have to do is you have to test each one of them. Of course, we always started from the smallest one. So let's try the 1. So let's try the 1. Oh, this one we're very lucky. So as soon as we try the 1, the remainder is 0. So that means x minus 1 is one of the factors. So then in this case, you would use this one, your original function, divided by x subtract 1. And then from there, you know you will get a quadratic function, right? So now here you would have x to the power of 2. So then that is x to the power of 3. Subtract x to the power of 2. So this is, again, this is -8 to the x to the power of 2 plus 20x. And then so -8x. So then you have next -8x to the power of 2 plus 8x. So 20 subtract 8x, 12x minus 12. So then that will be plus 12. All right, so then you can see this is definitely 12x, subtract 12. So that's because it is one of the factors, remainder is 0. So then this is your quadratic function. So now you can rewrite it into x minus 1. So your original px, or your original fx, I'm not going to copy it, it's too long. And then that breaks into this, a linear function multiplied by a quadratic function. And then this time you can factor this out, right? So then you factor this out, is that and x minus 2, x minus 6. And you got all your other 2 roots here too, so 2 and 6. So therefore your zeros is x equals 2, 1, 2, and 6. Now, next example is exactly the same thing. So you just have to try. So now here, this one is a cubic function, and then break this into, this is only 1 and 2 and 3 and 6. So basically 1 and 6, 2 and 3. So thankfully we got this only 4 on top. But this one now is not 1 anymore, so you have to break that one. So that is 1 and 4, and 2 and 2, and 2 and 2 repeat themselves. So you got 1 and a 2 and a 4. So then all these ones divided by 1, sure, that's not a problem. Oh, sorry, this room has this heater that comes on to blow hot airs, and it's very scary. And now I just came up. It scared me before, but this time I prepared. Sorry, you guys will hear this in the recording. So now we have a 1, 2, 3 positive, negative here already, and 6. So we already got this ones. And then after that, we use this one, the top 4 divided by 2, and we got this 1 again. And then we have 1 over 2. So we got 1 over 2. We got 2, that's 1 again. And we got 1 over 4, so we got 1 over 4. And then we use a 3 divided by that, that's fine, that's just a 3. And then this is 3 over 2. 3 over 2 is already here. And 3 over 4, 3 over 4 is here. Now this one divided by 1, that is 6. We already have that. And this already have 3. And then we already have 3 over 2. All right? So our possible zeros or possible roots are this many. So we just have to test them each one by one. So starting with positive 1, negative 1. Unfortunately, the remainder is not 0. So these guys are not, change the color. So these are not our zeros. Too bad. And then we're going to test positive 2, negative 2. And it happens to be that the negative 2 is one of the zeros. So negative 2 is good. So then therefore, we can get out of this negative 2. So become divided by x plus 2. And then now we have this quadratic function here. And then you just use your factoring, and then you get this 2, and then you figure out the roots. Wow, I wish that this blower could stop, but it's going to be on for quite some time. So let me just say the steps for, so pretty much like we know that a cubic function is probably the highest that we're going to get you to understand how to locate the 3 roots. All right. So the matter of fact is using the theorem. The first step is using the theorem. Use the theorem to locate one factor oh, I hate this pen. I cannot write it well, or the writing board. Now the second is using the long division. So use the long division to locate or determine the quadratic function. I'm just using the quadratic function. All right. Now the third one is to factor quadratic function. And then the third one, you have 3 roots. 3 roots are determined. All right, so now let's take a look at your exercise, okay? So these ones are very boring. This is just basically you plug this number in, and then you see whether or not you calculate the remainder. The only thing I find interesting in terms of solving is pretty much just this question here. However, you can see this is a cubic function, but that already gives you one of the factors, one factor. So then you just have to use this one to divide by that and give you another, give you the quadratic, and then you just factor it. So then that's it. So we don't use the synthetic, just use the long division. If you know how to use the synthetic, you can go ahead and do it, not a problem. Now this one is another thing, another factor is given. All right, so now this one, 2 factors are given. So it just after you use the division, and then you will get this 2. Now this one here, you see, if you factor the 3rd out, the 3 out, and then you already have just 1 bracket left. Now this one is, this is already 2 roots already out here, and then you would have to find the other 2. So only this question is very interesting. But then again, this question is if you use a long division. This is why I'm saying this one you cannot even use the synthetic to get this. So use long division, then you would have a cubic function. From the cubic function, use the rational root theorem to figure out another root here, and then from there to figure out the another factors for your quadratic function. All right, so I find this question very interesting.